This is Math 6, Lesson 1-6, Comparing and Ordering Decimals. You can compare and order decimals in several ways. One way is to use models. And there are several different models that you can use. Let's take a look at the numbers 0.24 and 0.3, 24 hundredths and 3 tenths. We can use a gridded model to compare the numbers, or we can use a number line. If we were going to use a gridded model, 24 hundredths, if we took a larger box and we were to break it into 100 equal pieces, we would shade 24 of them, which is what we've done here. These would be 24 shaded boxes. Or we can use the same size box, but instead of breaking it down to 100 squares, we could break it down to 10 lines. Instead we just drew the vertical lines and didn't draw the horizontal lines with it. And if we color in 3 tenths, that would be the same as coloring in 30 little squares. You can clearly see that you have 3 full lines colored here and only 2 and a little part over here, which means that 0.24 is definitely smaller than 0.3. The second way we can do this is we can look at a number line. Let's take a look at the following 2 number lines. We have a number line. The first number line starts at 0.00 and goes to 0.01, 0.02, 0.03, and so on. So if I found 0.24, okay, on this number line, okay, it would be very difficult because it's such a small number line. I can't fit 0.24 on the top number line. Okay, it's essentially 2 number lines put together. This first number line here and this second number line here make one giant number line, but we've broken it apart. So if I find 0.24, 0.24 is right here. 0.3 is right here. On a number line, the further you get to the right of a number line, the bigger the numbers get. This number here is bigger. It's further to the right than this number here, which is smaller. So again, we know that 0.24 is smaller than 0.3. Now, using models is helpful to visually see which number is bigger or smaller. However, it doesn't help if you have lots of decimals that you need to compare, because you don't always have time to draw 100 boxes, or heaven forbid if it was like 456.397, which means you'd have to be drawing thousands of boxes, or having number lines that went that large. So a second way to compare numbers, especially decimals, is to look at their place values. If I wanted to compare decimals looking at their place values, the first thing I would do would be to line up my decimals. For example, if I have the problem 0.56 and 0.543, I have 0.56 and 0.543. As you can see, this top one here only has 2 digits after the decimal point. The bottom one has 3 digits after the decimal point. To compare them, I need to make sure they both have 3 digits. So I'm going to add a 0 after my 6. Then I'm just going to start comparing things. If I was to look at the first set of numbers here, if I look at the 5s, those are equal. Okay? Those numbers are equal. If I look at the second set of numbers, I'm going to look at the second, or the tenths position, or excuse me, the hundredths position. If I look at the hundredths position, I have a 6 and I have a 4. Well, 6 is bigger than 4, which means 500. If I left it, 560, okay, 56 hundredths is larger than 543 thousandths. If I was to look at these numbers without the decimal point, excuse me, I messed up my. Without the decimal point, I have here 560. I have here 543. Well, 560 is bigger than 543. So 0.560 would be bigger than 0.543, which means this number is larger. Now you might look at me and say, but I already know all of these. I can do this in my head. That is fine. If this is something that you can do in your head, there's not a whole lot of work to be shown. If you need to show your work so that you can show me, then that's great. If we look at number 3 here, 0.1 and 0.10, I have 1/10, 1/10, and 10 hundredths. Right? If I give the same place value, I have to add a 0 to the top one. I can see, oh look, these are equal. 10 hundredths and 1/10 is the same thing, so these are equal right here. Number 4 here, 0.28 and 0.82. 0.82. I have 28 hundredths or 82 hundredths. Think of this as change. I have 28 cents or I have 82 cents. Which one is larger? Well, 82 cents is much bigger than 28 cents. Okay? So if I was to list these, if I was to look at these two digits right here, 8 is larger than 2. Therefore, 82 hundredths is larger than 28 hundredths. Number 5, 6/10 or 6 hundredths. 0.6, 0.06. Right? 6/10 is the same as saying 60 cents, because I have 6 tens, which means 6 dimes. 6 hundredths is I have 6 pennies. I would rather have 6 dimes than 6 pennies, because 6 dimes means I have 60 cents versus 6 cents. So 0.06 is larger than 0.6 is larger than 0.06. The last thing you have to do is you have to be able to order numbers. Ordering numbers from least to greatest, smallest to largest, or largest to smallest. You have to pay attention to what they're asking you to do. So always make sure you know if they want it big to small or small to big. Here they want small to big. So I'm just going to list my numbers vertically so that I can compare their place values. So I have 3.059, 3.64, and I'm going to add a 0 so they have the same number of places. And I have 3.46. I'm also going to add another 0 so they have the same number of places. All the whole numbers are the same. They're 3. So now I need to look at these place values right here. If I look at these place values right here, 6 is bigger than 4, and 4 is bigger than 0. So 0 is my smallest number. So this is my smallest number. This is my second smallest number. And this is my largest number right here. So 3.059 is my smallest number. 3.460 is my second smallest number. And 3.640 is my largest number. Since we have to write these in their original form, if we're gonna order them, we have to list them in their original form. We can't just number them like I did. The numbering part makes it so my brain knows which one goes first when I go to write it down. But when I write it down, I have to put it in the original form. So I have 3.059. I'm going to use a semicolon so that I can separate my numbers and I don't get things confused. My second largest number was 3.46. Notice I dropped the 0 off because originally it didn't have a 0 when we wrote it. You write it back in its original form. And the last number is 3.64. Again, dropping that 0 off because it didn't have it originally. So there's my 3 numbers written from smallest to largest. This next problem, we're going to do the same thing. So I'm going to take my numbers, 0.8. I know I'm going to need to have at least 2 zeros because I have 3 digits here. So I'm going to have 0.084, 0.48, annex a 0, and 0.84, annex a 0. So smallest to largest, the first things I have to do is I have to compare the very first set of digits where they change, and that would be right here. If I'm looking at these numbers right here, 0 is smaller than 4 and 8, so this number comes first. 4 is smaller than 8, so this number comes second. Now I have to compare my 2 remaining numbers. I have to compare the 2 numbers that I have left, which happen to be this number here and this number here. So now I have to compare the next set of digits, which is the ones that I've highlighted in green. So out of the 2 that are highlighted in both blue and green, 4 is larger than 0. So 0.800 would be my third largest number, and then my very largest number is this number right there. So the order in which we would write these, 0.84 is my first number. My second largest number is 0. Yes, that's right. I just wrote it wrong. Let me rewrite this properly. 0.084. I forgot my first zero. That messed everything up. My second largest number is 0.48, and I leave my extra zero out because I only annexed that zero so I could compare to decimal places. I have to rewrite it in its original form. Then my third largest number is 0.8. And my very largest number is 0.84. And you can see that that's the order in which these numbers should go.